Why, Lady Gaga, what brings you to the airport?
I am heading back to school from my Thanksgiving break. We have finals coming up now before we can celebrate the day of your birth, and I am especially stressed out about my organic chemistry class.
That is great. You are making an initiative to step outside your box to learn rather than singing about poker faces and bad romances all the time.
Thank you. I am trying to learn mechanisms so I can eventually synthesize a solution I can put on my hot dog dress so I won't smell, and people will actually want to be around me. Jesus, I trust in you and believe you know all. WWJD.
First things first. Resonance and formal charges are the key to success in that course. Resonance is the delocalization of electrons over several atoms, which helps to add stability to thy molecule. As electrons are delocalized, keep in mind that each atom needs an adequate amount of electrons, so a positive or negative formal charge may be needed.
I feel like those are basic concepts. Please preach some more.
Indeed, thy information is basic but key for progression. For example, thy memorization of thou pKs, functional groups, polar solvents such as methanol, and nonpolar solvents such as acetic acid are simple yet necessary to learn. Flashcards work wonders for this kind of material.
Thank you. I will do that while my stylist does my hair in order to use time more wisely.
As that material is perfected, you will need to understand what nucleophiles and electrophiles are. Acid-base mechanisms are the most basic reactions to understand this concept. A base is a nucleophile or anything with a negative charge that can attack an electrophile and accepts protons. An electrophile is an acid, which has a positive charge and gives up protons.
What does all of this have to do with pKs?
Well, Lady Gaga, the lower the pK, the more acidic the molecule is. Acids must be stronger than the conjugate acids for the reaction to occur, and the pK for the conjugate base is always greater than the acid.
Okay, now everything is coming together.
This information will be pertinent when you review elimination, substitution, and addition reactions. With these reactions you can see how nucleophiles attack electrophiles, the loss of a leaving group, and how protons are transferred for the desired product.
I do remember in most of the mechanisms covered that the most stable carbocation must be formed by doing either a hydride shift or a methyl shift. Am I right?
You are absolutely correct. Maybe you can make a song about it?
Oh no. I need to be focused on organic chemistry because if I'm recalling correctly, the mechanisms are very intensive and require a lot of practicing with the practice problems in the book. Could you please give me the breakdown of each mechanism for review?
Basically, for elimination there are two reactions, the E1 and E2. Each of these gets rid of a group from a molecule to form an alkene. The E1 is rate dependent only on the concentration of the substrate. It happens in two steps and prefers a tertiary carbocation for stability. The E1 also prefers a trans stereoisomer and only forms the Zaitsev product, and is not stereospecific. Now can you tell me about the E2 mechanism?
The E2 mechanism is dependent on the concentration of the base and substrate, right?
Yes, it also produces cis and trans isomers. The Zaitsev product is the major product with a regularly charged base, while the Hoffman product is the major product when a big bulky base is used to attack. Like the E1, the tertiary carbocation is preferred.
Jesus, my flight is going to be boarding soon, so we need to hurry to make it through substitution and addition reactions.
Patience. In that case we will cover substitution and you can go over addition on your own. For substitution there are two different mechanisms, an SN1 and an SN2. The SN1 occurs in two steps and its rate is dependent on the concentration of the electrophile. The first step is the rate determining step and is the loss of a leaving group to form a carbocation. The second step is the nucleophilic attack. Tertiary carbocations are best and racemization occurs. The strength of the nucleophile doesn't matter. Are you understanding any of this?
Yes, Jesus, I am following you.
Okay, then I'm going to continue with the SN2 reaction. These reactions occur in one step and its rate is dependent on both the electrophile and nucleophile. Inversion of configuration occurs in a primary carbocation works best for nucleophilic attacks. SN2 reactions prefer a strong nucleophile, needs a leaving group more stable than the nucleophile coming to displace it, and uses a polar aprotic solvent.
This is great. So once I perfect all these mechanisms, I can synthesize my special solution?
Not necessarily. You still need to take organic chemistry too. And next time we have an encounter, dress more modestly. Merry Christmas and have fun celebrating my 2011th birthday after your finals.